Radio signals have a polarization. So if you have a vertical antenna, if you have a car, now, I'm not very good at drawing cars, so we'll sort of, a car, very often, like a CB aerial or anything else, that will have an antenna on the roof. That is vertically polarized. And what actually that means is that the signals come off vertically, okay? However, if we go back in the book all the way, remember the chimney with the Yagi antenna? Very often a Yagi will be horizontal. It could be vertical, by the way, but very often it is horizontal. So we have horizontal and we have vertical polarization. So if I've got a little dipole, I've got a tree, a purple tree, and I've got a horizontal dipole in that tree. So there's my feed point, and then we'll put this in red. The horizontal dipole there. And my friend, a few miles away, has got a vertical antenna. The difference between the two, there'll be some loss. The maximum loss between two different polarizations is 20 decibels. If you like, one way of thinking about this is if we've got a polarization going that way and a polarization going this way, where they intersect in the middle is about 1/100th of the difference. So you end up getting about 1% of the signal in the middle. As soon as you start going off from there just a little bit, that 20 dB becomes 15, 10 very quickly. So we have horizontal and we have vertical. Now there's another type of polarization. You can have, and we'll look down the back of a Yagi here, right, where there's a, let's put a boom in, right, boom on a Yagi, big TV antenna. We're looking down the back of it now, okay? There's another type of antenna, circular. They call it circular. I've got it on the page here, circular polarization. So what happens there, we've got a number of elements and they are both that way and that way, okay? And then there's a funny mismatch. You actually have two pieces of coax, one a bit longer than the other. And what happens is the RF literally comes off circularly polarized. And depending on which way you feed, with the vertical or the horizontal, depending whether you'll have left-hand polarization or right-hand polarization. There's a graphic on the screen here. It looks like left-hand polarization by the look of it, but whatever. Why do we need that? That's interesting. It's not in the syllabus, this bit, by the way. But very often radio towers, not AM radio towers, but the FM, they'll flood the local sort of 50-mile area with a circular polarized signal, because if you try and pick up a circular polarization radio signals with a vertical, there's only a 3 dB loss. You're only losing half the power. So it actually doesn't really matter if you've got a Yagi, a dipole, a straight vertical, anything else. The commercial businesses very often do circular polarization. So everybody can, you don't need a specialist antenna. That's what they're doing. On HF, shortwave, a lot of amateur radio stations, and if you're an AM DXer, in other words, you're after really interesting stations on the other side of the Atlantic or whatever, on AM, the shortwave bands, you'll think to yourself, well, what polarization is that? Well, actually, it doesn't matter. Because if we just go back a couple of pages in my book here, we were talking about this. You've got the Earth's surface here, and then here in pinky purple, we've got the ionosphere. And as signal goes up, that was these red lines, goes up, bounces, so it refracts, if you remember, off the ionosphere and comes back down. Well, is that coming back down vertically, horizontally, slanted? It could be anything, because once it starts going through the ionosphere, it goes all sorts of ways. Now, if you're a ham radio operator, for instance, and you're hearing a DX station, or even just a local station a couple of 100 miles away on the 40-meter band, so you're getting this, what we call, if you remember, NVIS, the near vertical incidence skywave propagation, what you'll find is the polarisation will twist. There's a really cool trick because there's something called a 2VFO radio. So you can buy a radio, sometimes called big knob, little knob, and inside it's got two radios, right? And you've got two jacks on the back. So you could put, for instance, a dipole on one jack and you can put a vertical on the other jack. And if you listen on both, you'll hear sometimes the signal will drift from your left ear to the right ear. If you've only got one antenna, you think, oh, it's all fading out. In fact, what's happening is the polarisation is changing. So this is page 15, right, of the foundation book. I'm just checking the syllabus, anything we've missed. It's telling us there is a convention, actually, on VHF FM. It's normally, most people will transmit vertically. So they'll have, on top of my house, I've got they call it a white stick. It's a big white fiberglass antenna. That means I can talk to all the other mobiles within 20 miles of here, you know. But that's on FM, which is the kind of chit-chat sort of mode on the 2 meter band, and UHF. That's VHF and UHF. And then for SSB, longer distance stuff, we normally use a Yagi, and that will be what they call on the flat side, okay? So on top of the chimney with a rotator, you know. That's normally horizontal. So FM is normally vertical, SSB is normally horizontal. There's not much to polarisation. In fact, if you are starting off in amateur radio or the science or the fun of radio signals, that's all you need to know. There's vertical and horizontal polarisation. And for long distance, shortwave DX, it doesn't actually matter. And then for FM, we normally use a vertical, and for SSB, this is on UHF and VHF, we'd normally use horizontal. And that's it. And then we got this circular polarisation. Incidentally, I can just hear the comments now. What happens? Is there such a thing as slant polarisation? Well, I suppose there could be, but as long as your friend has got the same slant, if you know what I mean, but you never quite know where everybody's going to be. I'm not expecting a lot of people to view this video. It's very, very specialist. So maybe let's make up for it and tell YouTube it's good. Give me a like or something. Say something nice, you know, in the comments. Hell, subscribe. You never know. If this is the 4th, 5th, 6th, 10th video you've watched of mine, maybe it's about time you bookmark the channel with a subscription. Doesn't matter, but it tells other people like-minded to you they might want to watch my channel, and I want to spread the word, frankly. Okay? Have a great day now. Thanks for tuning in. I'll see you next time. Bye for now. 1, 2. Get started here. Sometimes I'm just trying to find the first few words. Right, radio signals have a pod. Start again.